Hello, hello. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in the Databricks playlist, and in this particular video we are going to cover what are Databricks components, what all different components are there in the Databricks, and how we can utilize them to work efficiently in the Databricks environment. We are also going to see how many different types of connectors are there that we can connect to using the Databricks connectors. So in this particular playlist, we have covered Spark from the very basics till the advanced concepts. So if you are someone who is trying to learn Spark from the basics or someone who only needs to cover the advanced concepts, this particular playlist can be helpful for you guys. So let's get started with this video and let's get straight into our system. Okay, so today we will be covering the Databricks components from the documentation itself, and we'll be seeing what all different components are there in Databricks, right? And how we can utilize each of them to get our requirement fulfilled and to even work very efficiently in the Databricks environment. Okay. So Databricks components, this article introduces fundamental components you need to understand in order to use Databricks efficiently, right? So the very first component that we have are accounts and workspaces. So in Databricks, a workspace is a Databricks deployment in the cloud that functions as an environment for your team to access Databricks assets. Okay. Your organization can choose to have either multiple workspaces or just one depending on its needs. Okay. So if I talk about or if I compare it with the local development, so we generally have some folders or some environments that we create for every individual projects, right? It's not that we keep all the projects and all the source code in one single folder, right? So same goes with this workspace. That workspace can be compared with the folders, right? That one of the project or one of the source code of one project will reside in maybe one workspace. The second can be there in the second workspace and so on. Then there is something called as Databricks account. So a Databricks account represents a single entity that can include multiple workspaces. Accounts enabled for Unity Catalog can be used to manage users their access to data centrally across all the platform in the account. Billing and support are also handled at the account level. So what the hierarchy is in the Databricks. So let me open my Epic Pen. So the hierarchy is something like this, that we have an account, right? And beneath this account, we can have multiple workspaces. So this can be, let's say, workspace 1. This can be workspace 2. This can be workspace 3. And these workspaces can cater to different projects. So let's say project 1, project 2 and project 3, or maybe for even different clients we can use different workspaces, because obviously none of the client will want that, okay, maybe their data or their code is shared with some other client, right? So for different clients, if we are managing different clients, so we can manage the clients in a separate workspace. So this is how we can use workspace. For accounting, we can have one single account or one single enterprise account, maybe for our Databricks, like for the billing purpose, for support purpose, and even for the Unity catalog thing. Everything can be managed under one single account. Okay. Talking about the billing. So billing, I would say, if we are talking about a large enterprise, right, or a large company, so billing plays one of the most important role while choosing any platform. Okay. Like why some companies migrate from, let's suppose, AWS to Azure or GCP. It's not that AWS is not giving them all those services or it's not able to fulfill their requirements. It's majorly due to the billing aspect. They may save millions of dollars while migrating from one cloud to another. Okay. So even before choosing that if we will use that particular platform or not, we always estimate the price. Okay. So Databricks billing is based on Databricks unit. So Databricks, how it consumes or how it bills anyone is by utilizing something called as DBU, that is Databricks units, which are units of processing capability per hour based on the VM instance type. Okay, so what kind of virtual machine, or maybe what size of virtual machine we are using? So every size of virtual machine will have some kind of processing capability. Okay, every kind of virtual machine will have some kind of processing capability, and how much processing it can do per hour, it will be based on the DBUs, right? So if we just click on this particular link, right, so you will be able to see here I can do. So let's suppose we are going ahead with the premium plan. I'm using, let's say, AWS as the cloud, and I want to use maybe SQL serverless compute. Okay, and maybe I can use region as Mumbai. Okay, now I can see what all instances are there. So if I talk about the two extra small instance, right, so how many DBUs per hour it will consume? It will consume 4 DBU per hour. It means Databricks unit per hour it will consume, and the rate of 4 DBUs per hour will be nothing but $3 per hour. Similarly, extra small instance will consume 6 DBU, and the rate of it will be $4.6 per hour. Similarly, if I talk about 4 Excel, so it will consume 528 DBU per hours. So 528 DBU is equivalent to $406 per hour. Okay. Similarly, even here also you can maybe do some kind of price calculation. Let's say if you want to add let's say this, right, you can select any of the instance. I want 2 instances and I want it for, let's say, 20 hours, right? And I can even compute again. Let's say if I want to take this, right, this something like this, right, 2 instances, 5 Excel, why it's not giving us the charges? Okay, total monthly cost will be this. If I include, sorry, if I add something else, let's say if I am adding this per hour, ideally it should give, add compute, remove compute. Okay, enterprise. Yeah, I'm giving 20 hours per day, let's say 5 days per month, let's say 20. Okay, okay, I had not filled all the values, so that's the reason we were not getting the estimate. Okay, so let's say if I use this lake flow job classic photon, so it cost $0.2 per DBU. Okay, so we are taking this 5 M5 DXL photon, right? We will be having 20 instances that will be running 5 hours a day, right, and 20 days a month, right? So total DBU users will be this much, pricing will be this much. If I want to add some more computes, okay, let's say if I want to add this, okay, I can add this. I can, let's say, 24 hours a day, okay, 30 days a month, right? So again we are getting this, and this is our total estimate bill. So this is how we can easily get some kind of price estimate. So this is not the exact bill that you will be getting, but this is a kind of estimate near about these are the bills that you will be getting. Okay, so this is, here you can calculate your price, and even based on the cloud, if you want to go ahead with Azure, right, so Azure pricing estimate, if you want to go ahead with GCP, you can estimate your price for GCP. Okay, let's move forward. Then there is something called as authentication and authorization. Okay, so this section describes concept you need to understand. You need to know how to manage Databricks identities and their access to Databricks assets. Okay, so there is a difference between authentication and authorization. Okay, so what authentication means is that you have to prove yourself that okay, I am this XYZ person. So whenever I am logging into, let's suppose, my Instagram account, so I have to authenticate myself that okay, I am Vishal and I want to log into my account, right? So either I have to put my email, right, I may have to put my password. Then if I have enabled some kind of two-factor authentication, I have to put some kind of OTP, and after doing all those things, I am authenticated and given the access that okay, yes, you are Vishal and you can access your account. So that is what authentication is. What authorization is, that do I have the authority to do that particular thing or not? Means, let's say if I compare it with the Instagram again. So let's say there is some kind of like some profile is a private profile. Okay. So if I have the access to, like if I have followed and that private profile person has accepted my follow request, then only I will be able to view his or her profile, else I will not be able to view the profile, right? So this is this is an authorization, that am I authorized to view that particular profile or not? Okay, does it comes into my rights, right? Or like, do I have the access to do that particular thing or not? If I talk about, let's suppose the Databricks aspect, right? So if I log into my Databricks account, so that is authentication, right? Now if I want to access maybe some table or some volume, okay, so in that particular case, what is the authorization do I have, and what level of authorization do I have? Okay, so can I write in that particular table or not? Do I only have, let's say, let's suppose read authorization or read access to that particular table, right? Maybe can I add some other person to that particular table or not? Do I have that access or not? All these things are like all these things comes into the authorization aspect of this. Okay. So the very first thing is the user. So a unique individual who has the access to system. Okay. So user is the most granular level of thing, right? User identifies identities are represented by email addresses, right? So whenever we log into our Databricks account, we have to we have to insert our email, right? Then we have to insert the OTP, and then we are logged into the system, right? Then we have service principal. So a service identity for use with job, automated tools and systems such as scripts, applications, and CI/CD platform. Service principals are represented by an application ID. Okay. So service principal is basically a kind of, I would say, a resource ID, right? That can be utilized if we are trying to automate something, if you are using some automation tools, if you are writing some scripts, right? Maybe integrating with our application or performing any kind of CI/CD on the platform. In that particular case, we don't have to authenticate using our email. We can authenticate using the service principal thing. Okay. Then we have something called as group. So a collection of identities. Group simplify identity management, making it easier to assign access to workspaces, data, and other secureable objects. All Databricks identities can be assigned as member of groups. Okay. So groups, again, as we know, that multiple individual or multiple users can be added as a collection inside a group, and we can give the access, we can give the authorization to those group level also. Okay. Let's suppose I can add all the data scientists in my organization in a data science group, right? And if I want to give the access, a tables access to the data science team, I can give the access to the group only. I don't have to add all the people in the data science team like one by one, right? I can give the access to whole of the group, and anyone or everyone attached in that particular group will have the access to that particular table. Okay. Then we have something called as access control list. So a list of permission attached to workspace, okay, cluster, job, table, or experiment. Okay. Right. So access control list is the list that controls the authorization of users. Okay. How? I will just now show you in a while. Okay. And what all resources do access list controls? So it controls workspace access, cluster access, job access, table access, and even the experiment. And ACL specifies which user or system processes are granted access to the objects, as well as what operations are allowed on the assets. Okay. Each entry in a typical ACL specifies a subject or an operation. So if we open this link, that is access control list, right? So here you can see in Databricks, you can use ACL to configure permission to access workspace level objects. Workspace admins can manage permission on all objects in their workspace, which gives them the ability to manage permissions on all the objects in their workspace. Okay, means the admin will have all the rights and all the access that who should access which object, right? Object means, let's suppose he can only have the access of, let's say, only the compute, or maybe only volumes, right? Or on whatever granular level it is, right? Let's say only he can access the cluster, or only he can access the job, only he can access the table, or multiple of things, arrays of these things he can access, right? And what is the level of access? So if I talk about, let's say, compute, okay, so in compute, what all abilities a person can have? So he can have maybe no permission. So if he falls into no permission, it means he will basically not have the access to this particular compute resource. Okay, then to attach a notebook to compute, so he can have access, like can attach to, if he can restart or not, or if he can manage that compute or not, right? Then view Spark UI, so can only attach, can restart, can manage, right? So all these things, like this is a very very granular level of authorization that you can give to anyone, right? Similarly, you can have the access control list for dashboard, for the legacy dashboard. So right now it's deprecated, right? For database instances, okay, lake flow, declarative pipelines, then features of table, if he can read the table, if he can view the metadata or not, if he can edit, he can manage the table or not, right? Search, table feature, publish feature, write, update, modify, delete. Okay, so all these things are there. Then file access control list, folder access control list. So there are many control lists that we can have. For jobs we have, right? So this is the granular level of control that we can give to anyone, so that, like, moving forward, all the things are, I would say, secure. Okay, nobody has such kind of access that he can maybe do some kind of alteration, unwanted alteration to our pipeline or to our whole system that we have created. So this is the use of access control list. Then we have something called as personal access token. So a personal access token is a string used to authenticate REST API calls, technology partner connections, and other tools. Okay, so personal access token is basically, I would say, a key, right? And kind of API key that's given, right? Where we can, if we want to go ahead with some kind of APIs, right? So moving forward, we will see that we can also interact with the Databricks, not only with the UI, but we can also interact with the CLI part of it. Okay, so if I want to authenticate this, that okay, I am Vishal, so how will I be able to authenticate is, like Databricks will give me a unique API key, or I would say a personal access token to me. Okay, that will be unique only for me. And if I only provide that personal access token, right, correctly, then Databricks will be able to authenticate that, okay, yeah, he is Vishal and he can do whatever authority he has in the Databricks environment. Similarly, every user will have his own unique personal access token attached to him or her. Okay, then we have Databricks interfaces, right? So in this section describes the interfaces for accessing your Databricks, your assets in Databricks. So how we can interact, or what all interfaces do we have? So the very first interface is the UI. So the Databricks UI is the graphical interface for interacting with features such as workspace folders and their contained objects, data objects, and computational resources, right? So this is the UI. This only thing is the UI that it's talking about, right? So using this UI, we can interact, we can have the access to all the things, workspaces, catalogs, jobs, right, compute, and whatnot. Everything we can access using this particular UI, right? Then we have something called as REST API. Okay, so the Databricks REST API provides endpoints for modifying or requesting information about Databricks account and workspace objects. Okay, So even using API, so just like we were using Spark.sql and all those things, so we were using Spark SQL API in that particular case. So similarly, using the REST API also, we can interact with our Databricks environment, right? How we can do it? So let's suppose if I have a condition, right, where I have a condition that, let's say my Databricks compute bill is, if it is greater than 500, you can shut down all the computes. Obviously this is not a very good logical thing, right? Obviously we will not be shutting down our compute anytime, right? But, or maybe send me an email. Okay, I guess that is a better thing, right? That if my bill sorry guys, okay, so let's say if I am having some kind of condition that if my bill exceeds more than $500, you send me an email to whatever email I have given. Okay, so in that particular case, will I have to do this particular thing manually? That okay, I am checking my bill daily, right? And once this bill exceeds 500, I will be sending an email to whatever XYZ given email is there, right? Then there is no kind of automation there. What I can do is, let's say there is no feature provided by AWS. Generally all the platforms have these features that okay, if your bill exceeds the given threshold, we will mail you, right? Every platform has this feature, but let's say Databricks is not having this feature, right? So we can write some kind of Python script or maybe a JavaScript script uh, to create our own feature, right? Something like this. So there I will be using the REST API of Databricks. I will be using API of like the compute, or I would say not of even of the compute, of the billing. I can use the billing API. I can fetch the bill on a maybe a daily basis or on an hourly basis using the API. And whenever my billing will exceed 500, it will automatically trigger the email. Maybe I can write a Python code for it and the feature will be ready for us. There no kind of manual interaction will be there using the UI. So this is how the REST API can be helpful for us. Then something called as SQL REST API. Okay, so the SQL REST API allows you to automate task on SQL objects. Okay, so let's say if we want to run some kind of SQL scripts on a daily basis, right? Maybe on a even on a weekly basis. So you can use SQL REST API for doing the job. Then we have a CLI also. So the Databricks CLI is hosted on GitHub. The CLI is built on top of the Databricks REST API. Okay. So CLI stands for command line interface. So we have these terminals like Git Bash terminal or PowerShell, right? So if I show you, so PowerShell. So this is a CLI, right? I can interact with my system using this Windows PowerShell also, right? Let's suppose if I want to list all the directories I have, right? So I can list all the directories using the ls command. Let's suppose if I want to go into any of the folders, okay? If I want to go into, let's suppose, documents, so I can do what? CD documents, right? And I will go inside documents folder. So either I can use the UI or the folder structure that I have, or I can use this CLI to interact with the system, right? So similar kind of CLI is also provided by Databricks. Okay, so these are the different ways or the different methods you can interact with your Databricks environment. Okay, then we have the data management part. So this section describes the tools and logical objects used to organize and govern data in Databricks, right? The very first thing, and I would say one of the most important thing, is the Unity catalog. So Unity catalog is a unified governance solution for data and AI assets in Databricks that provides centralized access control, auditing, lineage, and data discovery capabilities across Databricks workspaces, right? I guess there is not too much to explain in this particular line. So Unity catalog gives us like the options that we can access or manage the control using what? Using the ACL, access control list. We can perform auditing. We can see the lineage of our data, right? That where exactly all the things began and what is the current state of our data is. Data discovering capabilities. All these things can be performed using the Unity catalog. Then we have something called as catalog. So catalogs are the highest level container for organizing and isolating data in Databricks. Okay. Again, not to get confused between Unity catalog and catalog. Unity catalog is the data governance model or the solution that we have inside our Databricks, right? It usually stores the metadata and all those stuffs. Catalog is basically you can say it's a container, it's a folder, right? That will be isolating everything, right? So here if I go, let's go to the UI, right? So here you will be able to see the catalog, right? And inside this catalog you have multiple things. We have workspace catalog, we have systems catalog and whatnot, right? So this is the highest level of you can say isolation, right? So we will have something as catalog. So let's say we can create one catalog for client 1, we can create one catalog for client 2. Then inside catalog we will have something called as schema. So schema, also known as databases, are contained within catalogs to provide more granular level of organization. They contain database objects, AI assets such as volumes, tables, functions, and models. Okay. So here for company 1 or organization 1, right, we can have again multiple databases, right? We can have multiple databases, right? And these two databases will be now isolated from each other. Obviously, none of the organization will want, or none of the companies basically will want that company 1 databases are shared with me or company 2 databases shared with company 1, right? So we can create a separate catalog for both of the companies or maybe the clients, you can say, right, for client 1 and client 2, right? And these clients, inside this catalog we can create the required databases, and inside this databases we can have the tables, volumes, right, model features and everything. Tables can be there, volumes can be there, and views can be there inside this what we call schema, or basically the database, right? Okay. Similarly, like you can see here also, right? This is the catalog, workspace catalog we are having, and inside this workspace catalog we have multiple databases, right? We have default database, information schema database, test database, and inside default database we have multiple tables and multiple volumes, right? We can have even the model registry and functions if we want to add here. Okay. Then we have something called as table. So table organizes and governs access to structured data. Keep this thing in your mind, right? And you will get your answer that why do we need volumes. Okay. So table organize and govern access to structured data. You query table with Apache Spark SQL and Apache Spark APIs. See you can see this documentation for more information. You can. Then we have something called as view. So a view is a read-only object derived from one or more tables and views. Views save queries that are defined against tables. Okay. So views, we are already aware about the fact that if we want to create some kind of maybe a temporary table, right? Or if we want to give some kind of granular level access for a particular table, or even for multiple tables, right? We can join multiple tables and create a view out of it, and we can give the access of that particular view to a group or maybe to a single user, depends on again on the use case. Okay. So we have already covered view in very deep in this particular playlist. Then we have something called as volumes. So volumes represent a logical volume of storage in a cloud object storage location and organize and governs access to a non-tabular data. Okay. Now the difference between table and volume, you must have understood that if the data is a non-tabular data, in that particular case we will require the volume to store that particular non-tabular or unstructured or semi-structured data. Okay. Databricks recommend using volumes for managing all access to non-tabular data on a cloud object storage. Okay. So usually Databricks in the backend uses the cloud object storage to create these volumes that will store the non-tabular or the unstructured or semi-structured data that we will be having. Okay. If we want to store the tabular data or the structured data, we can also use tables. Then we have something called as delta tables. So by default, all tables created in Databricks are delta tables. We are already aware about this fact. Delta tables are based on Delta Lake open source project, a framework for high performance ACID table storage over cloud object storages, right? So we are already aware about the fact that in lakehouse architecture, we have the acid properties with us, and that is one of the major pros of the lakehouse architecture, right? And this acid properties is provided by what? Acid properties is provided by nothing but the delta lake architecture, okay, or I would say the delta lake framework. Okay, a delta lake table stores data as a directory of files on cloud object storage and registers table metadata into metastore within the catalog and schema. Okay, so it will store the files in the directory of the cloud storage, and it will register all the metadata, right, into a metastore that will be within the Unity catalog, okay, for doing the access and all those things. Okay, Unity catalog, it will be using like managing the access, auditing and lineage, and everything will be handled by this metadata that will be pushed to the catalog and schema. Okay, then we have something called as metastore. So Unity catalog provides an account level metastores that registers metadata about data, AI and permissions about catalogs, schema and tables. Okay, so all these things will be managed by the metadata store. Okay, Databricks provides a legacy Hive metastore for customers that have not adapted to the Unity catalog. So this is older version, I would say, so we need not worry too much about it. Okay, then we have Catalog Explorer. So Catalog Explorer allows us to explore and manage data and AI assets, including schemas, that is databases, tables, models, volumes, that is non-tabular data, functions and registered ML models. You can use it to find data objects and owners, understand data relationship across tables, and manage permissions and sharing. So Catalog Explorer is basically, you can say, a kind of a UI, right, where you can manage everything, like managing the access to your schemas, tables, models and volumes, right, till exploring all the things like what all relations do we have between our tables, what all permissions are given to which users, and all these things are everything, each and everything regarding the governance, the data governance or the workspace governance will be there in the Catalog Explorer. Okay, then we have something as DBFS root. So DBFS root is a storage location available for all users by default. Okay, so DBFS, again, in the previous versions of Databricks, we were using DBFS as the root directory, but now it has been changed to the it has now been changed to this delta table storage. Okay, so we need not again worry too much about this particular part, right? Then we have something called as computation management. Okay, so this section will describe the concept that we need to know to run the computation in Databricks. Okay, the very first thing for a computation is the cluster. So a set of computation resources and configurations on which you run your notebook and jobs. Okay, so cluster is nothing but it's a collection of devices, or I would say not devices, it's a collection of machines, right? So we are already very well aware about the fact that this is master and these are the slave nodes, that Spark runs on this kind of master slave architecture, right? So these whole group of machines will be called as cluster. Okay, so this is called as cluster. Okay, and these are the machines where we will run our notebooks, right? Whatever things we are executing on the notebook, it's basically at the back end using some kind of computation to do it, right? So that particular thing is done nothing but using the cluster itself, right? And this is what we connect to, right? If we open any of the notebook, Okay, it will take a few seconds to open, right? Then we have two types of clusters. Okay, so you will create an all-purpose cluster using the UI, CLI, or REST API. Okay, you can manually terminate, restart an all-purpose cluster. Multiple users can share such clusters to do collaborative interactive analysis. Okay, so we have first of all something called as all-purpose cluster. So let me make this very clear to you guys that these clusters will be only accessible to us, or we will only be able to create these manual clusters by ourselves when we are going ahead with the premium edition or the paid edition. In the free edition, we don't have any kind of access or any kind of option to create our own compute. We can only use this serverless access that we have, right? So again, these serverless access are nothing but in the backend they are some kind of machines which are executing these codes that we are writing here in the notebook, right? If you are going ahead with the paid edition, we can create these clusters and these computes according to our own requirement and workspace that we want. Then we have something called as job clusters. Okay, so the Databricks job clusters creates a job cluster when you run a job on a new cluster and terminate the cluster when the job is completed. You cannot restart a job cluster. So whenever a job needs to run, right, we can create, or even the Databricks will create a job cluster by itself. It will run that particular job on that particular cluster, and then it will terminate once the job has been completed, right? And currently there is no such feature that we can again restart that particular cluster if we want to rerun that job again. If we want to rerun that job, a new job cluster will be created, right? Then we have something called as pool, right? So let's first of all understand what exactly pool is, and then we will see the concept. Okay, so a state of ideal ready to use instance that reduce cluster start and auto scaling times. Okay, when attached to a pool, a cluster allocates the drivers and worker nodes from the pool. Okay, if the pool does not have sufficient idle resources to accommodate cluster requests, the pool expands by allocating new instances from the instance provider. When an attached cluster is terminated, the instances it used are returned to the pool and can be reused by a different cluster. Okay, so a pool is nothing but a very large cluster, you can say. Oh, okay. Here we will have multiple machines running at the same time, and there can be two use cases of pools, right? We will have multiple machines running at the very same time, so these again machines will be connected to each other, right? Okay, so what we can do, let's suppose if we want to launch a cluster, so usually launching cluster takes a few minutes, right? But what we can do is either we can use this pool to launch the cluster. So as these machines are already running, right, what it will do is, let's suppose we want 16 GB of RAM, right? 16 GB RAM. Let's suppose we want 4 CPU, right? And let's say 100 GB of storage. Okay, this is my requirement for the cluster. Okay, so what it will do, it will check within these machines that okay, what all resources are empty, and whatever empty or idle resources will be there, it will create a cluster of these resources with the requirement that we have given to the pool. Okay, so this will reduce the cluster start time because the environment is already up and running for us. And if we want to auto scale, okay, if we want to upscale our instance, okay, in that particular case also we will not have to go ahead with the cold start. Okay, so there is a concept of cold start in DevOps. Okay, I will not go too much into deep, else the video will get first of all derailed. It's not our concept, or maybe a very important thing with regard of the Databricks, right? But you need to understand that if we want to upscale, means we want to attach more resources to our cluster, in that particular case also it will be automatically, let's say now I want to upgrade this particular thing to 32 GB RAM, 8 CPU, right, and 200 GB, right? So what it will again do, we will not have to spin up a new instance. It will again check that okay, what all empty resources are there, it will allocate it to the cluster. If there is a condition that it cannot fulfill the request, then it will spin up it will spin up the instances from the scratch. Okay, then only it will spin up the instance from the scratch. So this is the first thing. Secondly, what pool does is, so if if I talk about the large organizations which are dealing with multiples of petabytes of data on a daily basis, so these people also buy pool from Databricks. Okay, so let's say I'm Amazon, right? So me as Amazon, I want, let's suppose on a daily basis, I want 10,000 GB of RAM. Okay, let's say if I want 1000 cores of CPU and let's say 10 petabytes of storage on a daily basis, right? So in a very short notice of time, even maybe Databricks will not have these these figures of resources, right? There may be an issue to spin up these resources in a very short notice of time, right? So what AWS will do, or let's suppose Amazon will do, or maybe some other organization, some maybe Deloitte or KPMG will do, is they will buy a cluster of or I was to say a pool of this resource, right, for a longer period of time. Let's suppose it will buy for 3 years or maybe 2 years. So it will get a very heavy discount, right, upfront. It may get 50%, 60%, 70% discount if we are buying this heavy resource in one single go for a longer period of time, right? So it can buy this pool, right, and it can get its system up and running. And whatever now again my cluster requirement is for different departments, different projects and different teams, we can allocate the resource from this particular cluster, and we don't have to every time go to the Databricks to get our resources. So this is also a second use case for the pool. Okay, I hope you guys have understood the concept of pool, right? Then we have something called as Databricks runtime. So the set of core components that run on the cluster managed by Databricks. Okay, Databricks has the following runtimes. So we have two runtime basically while in the Databricks. So the first runtime includes Apache Spark, but also adds to a number of components and updates that subsequently improve the usability and performance of the security and big data analytics. Okay, so let's suppose if we want to do any kind of data analytics and big data job, in that particular case we will go ahead with the Apache Spark runtime, and the second runtime will be the machine learning runtime. Okay, so this machine learning is built on Databricks runtime that provides pre-built machine learning infrastructure that is integrated with all the capabilities of Databricks workspace. It contains multiple popular libraries including TensorFlow, Keras, PyTorch and XGBoost. Okay, so if we are working and if you are using, let's say, or if I want to do some kind of machine learning kind of stuff, so in that case I can go ahead with the machine learning runtime of Databricks, where it will already have these libraries that we use for training our machine learning models, that is PyTorch, Keras, right, TensorFlow and XGBoost. Okay, then we have some other components, that is jobs and pipeline UI. Okay, so the jobs and pipeline workspace UI provides the entry to jobs, Lakeflow Spark declarative pipeline and Lakeflow Connect UIs, which are tools that allow you to orchestrate and schedule workflows. Okay, so just like we use Airflow, right, similar kind of functionality is given in the Databricks environment also, that we can schedule our job. Let's say if we want to do some repetitive thing, we don't have to run all those things manually, right? We can schedule a job and based on the timing, right, it will automatically run those jobs, right? So first of all, we can create a job. So a job is nothing but a non-interactive mechanism for orchestrating and scheduling notebooks, libraries and other tasks, right? So we can schedule a notebook. Let's say we have written a script that I want that it should run every day at 5 a.m. Okay, so instead of manually coming and waking up at 5 a.m. and running that particular notebook, what I can do is I can schedule it, and every day 5 a.m. it will run automatically. Okay, Databricks will create a job cluster. We are already aware about this, right? It will create a job cluster, right? it will run that particular job, and once finished, it will automatically terminate that cluster. Okay. Then we have something called as pipeline. So Lakeflow Spark Declarative Pipeline provides a declarative framework for building maintainable, and testable data processing pipelines. Okay. So generally we have two types of coding standard, right? Declarative, and the other one is progressive or something like that. I'm not exactly remembering at this point of time. Okay. So generally we have two types of coding standards. Okay. So declarative means that we only declare that, okay, this is the output that we want, right? And then the process, the flow, and each and everything will be decided by the system itself. Okay. So we can do a declarative pipeline that, okay, this is the ETL process that I want, this is the end goal I want to achieve, and rest of the things, right, how it will run, what all processes will it run, what all different jobs will it make, all these things will be the headache of the system. Okay. Then we have something called as workload. So workload is the amount of processing capability needed to perform a task or a group of tasks. Databricks identifies two type of workloads. The first workload is the data engineering, that is job, and the second one is data analytics, that is all purpose. Okay. So data engineering and automatic workload runs on a job cluster, which the Databricks job cluster creates for each workload. Okay. Then we have data analytics and interactive workload runs on all purpose cluster. Interactive workload typically to run commands within a Databricks notebook. Okay. However, running a job on an existing all purpose cluster is also treated as interactive workload. Okay. So if we want to run any kind of automated part, right, if we want to run a job, if we want to run some kind of this pipelines and all these things, it will be considered as the data engineering workload. Okay. And if we are running anything interactively, means if we are running it using UI or maybe the notebook and all these things, it will be considered as a data analytics or an interactive workload. Okay. Because we are doing those things manually, we are interacting, right? We are writing the code, right? We are running the cell, we are seeing the output, and according to the output we are again writing the code. So this is an interactive process, right? So these are the two types of workload that Databricks usually has. Then we have execution context. So the state of the read eval print loop, okay, environment, that what all programming languages are supported. So the languages supported are Python, R, Scala, and SQL. We are already aware about this fact that these are the four languages that are supported in Databricks. Cool. Now let's understand about the data engineering environment. So the data engineering tools add collaboration among data scientists, data engineers, and data analysts and machine learning engineers, right? How it will it will add the collaboration between all these things. First of all, using the workspace. So we are already aware about workspace. It is an environment for accessing all the Databricks assets. A workspace organize objects, that is notebook, libraries, dashboard, experiment, etc. into folder to provide access to data object and computational resources. Then we have notebook. Again, we are very well aware about notebook, that it is a web-based interactive interface for creating data science and machine learning workflows that contains runnable commands, visualizations, and narrative text. Library. So a package of code available to the notebook for or job running on a cluster. Okay. Databricks runtime may include many libraries, or you can also upload your own. Okay. So libraries are nothing but a set of pre-written codes that is already written by some developers, and we only have to import or to install those libraries, and we can very well import and use the code written by them, just like we use pandas, right? So let's say if we do let's say pandas.read CSV, right? So this read CSV is a function that is already written by someone or some developer for us. We only have to do pip install pandas, right? And then pandas.read underscore CSV, and we can pass the file path and we can read the file, right? So all these things are provided us by library. Then we have Git folder, formerly called as repos. So a folder whose content are co-versioned together by syncing them to a remote Git repository. These folders integrate with Git to provide source and version control of our project, right? So if we want to do the version control thing, the source code control thing and all those things, it can be managed by Git. So we have already created a video on Git and we have discussed all those things in very detail. Then we have our AI and machine learning. So Databricks provides us an integrated end-to-end environment which managed services for developing and deploying AI and machine learning applications. We have something called as Mosaic AI. So it is a brand name of product and service for Databricks Mosaic AI Research, a team of researchers and engineers responsible for Databricks' biggest breakthrough in generative AI. Okay, Mosaic products include the ML and AI features in Databricks, right? So again, Mosaic AI, if you can talk about, so it is an organization, a group of researchers and developers who are basically handling the AI ML part in the Databricks. Okay. Then we have our machine learning runtime. So to help develop machine learning and AI models, Databricks provides a Databricks runtime for machine learning, which automates compute creation with pre-built machine learning and deep learning infrastructure, including the most common ML and DL libraries. It has also pre-built and pre-configured GPU support, including drivers and supporting libraries. Browse to inform more about the latest runtime and all those stuffs. Okay, so as we are already aware about that, there are two runtimes: machine learning runtime and the Spark runtime, or basically the data engineering runtime, right? So the machine learning runtime, it will have all the necessary libraries like PyTorch, TensorFlow, Keras, and all these things pre-installed along with the pre-configured GPU support. So if we want to train a large model, in that particular case, we require GPU to train those models, right? So it will also have the GPU support included in the machine learning runtime. Then we have something called as experiment. So a collection of ML flow runs for training and training a machine learning models. Okay. So when we are training the machine learning models, right, we like running one particular pipeline or doing one model training can be termed as an experiment, right? And it's not that there is something as data comes to us, we pass it to machine learning model, right? We train the machine learning model and the model is ready to use. This is not the exact flow. We train multiple models, then we compare those models, and whichever model is performing best, later on we also fine tune those models, right? This is the whole process, and which model performs the best, we choose that particular model, right? So running and creating one data or machine learning model is called as experiment. So MLflow is an open source platform or an open source tool that helps us to compare these elements, right, to kind of do a version control of the machine learning model runs and all these things, right? So these things are managed under the hood by MLflow. And when we were talking about this particular thing in the very first video, we have seen that even the developers of MLflow are a part of the Databricks team, right? Talking about the features. So features are important concept for machine learning models. A feature store enables feature sharing and discovery across your organization and also ensure that the same feature computation code is used for model training and inference. Okay. So feature is nothing but kind of creating new columns or getting new insights from the data that we already have, right? So that is called as feature. So for machine learning models, we can create features based on the data discovery and the data that we already have. Okay. Then we have our generative AI models. So Databricks supports the exploration, development, and deployment of Gen AI models also. It includes an AI playground, so a chat-like environment in the workspace where you can test, prompt, and compare LLM. Okay. So it is a kind of playground, right, where you can using a chat-like thing, just like we do in the chat GPT, right? We can have a workspace where we can test, right? We can prompt and we can even compare different LLMs, that which LLM suits are the best for the use case. Then we have pre-built pre-inbuilt set of pre-configured model that we can query, right? So there are different models that we already have that we can use as an API, right? So you can see here, these are the models that has already been deployed by Databricks, and these models can be used even here if we go onto our UI, right? And here if we go to servings, I guess, right? So these are the models that is already there for like already deployed by Databricks. We can just use these models. So you can see, right, this is the endpoint, API endpoint that we can utilize to serve, and based on the uses we will be charged. Okay. Then we have third party or hosted LLMs or the external models. These models are meant to be used as it is. And we have again the capabilities to customize a model based on its performance to your specific application, often called as fine tuning. Okay. So we can also, I would say, modify the model or maybe retrain the model in such a way that it can suit my use case. Okay, let's suppose if I'm having some kind of shopping application, right? So I can retrain the model in such a way that it knows more about my application and my services and my products, so that it can give a better result and a better output according to the use case that I have. So that is what it's called, the fine tuning of model. Okay. Then we have something called as model registry. So Databricks provides a hosted version of MLflow model registry in Unity catalog. Models registered in catalog inherit centralized access control, lineage, and cross workspace discovery and access. Okay. So again, like whatever model we are training, right, whatever metadata of those model trainings and everything is getting created, it is getting registered to the ML model registry, which is again a part of our Unity catalog. Okay. Then we have something called as model serving. So Mosaic AI model serving provides a unified interface to deploy, govern, and query AI models. These models you serve is available as a REST API, as already seen, right? This is a kind of REST API that we have, right? To integrate to your web or client application. With Mosaic AI model serving, you can deploy your own models, foundations, and third-party models hosted outside the Databricks also. Okay. Then we have something called as data warehousing, right? We have already talked about this particular concept in the previous video, so let's quickly understand it. Okay. Data warehousing refers to a collection or storing data from multiple sources that can be quickly accessed for business insights and reporting, right? So we have seen in the previous video that only the gold layer data is added to the data warehouse, and the data warehouse gets connected to the BI tool or the reporting tool to get the business insights of the data from right from the raw data to till the gold layer of the data. Okay. Databricks SQL is a collection of service that brings data warehousing capabilities and performance to the existing data lakes. Okay. Then talking about a query. So a query is a valid SQL statement that allows us to interact with your data. You can author queries in the in-platform SQL editor or connect using SQL connector, driver, or API, right? So we already were about to know that this is the SQL editor we can use to interact with the data warehouse that has been created in the Databricks environment, right? Then we have something called as SQL warehouse. So it is a computation resource on which you run your SQL query. There are three types of SQL warehouses: classic, pro, and serverless. Talking about the free edition, we only have the access to this serverless warehouse. But if we have the paid edition, we can also have the access of classic and pro. Databricks recommends using serverless warehouse where available, and you can see this link for the comparison of features between all these three types of warehouses. So SQL warehouse, again, it's nothing but a kind of compute, right? Just like we have cluster in for running our notebook, for running the SQL part or the SQL aspect of it, we have SQL warehouse as the compute, right? Here if you see, we have our serverless warehouse up and running for us. Okay, so this is, we can connect and we can do whatever we want, like in the SQL editor. Okay. Then we have query history. So a list of executed queries and performance characteristics. right? Query history allows you to monitor query performance, helping you identify the bottleneck and optimize query runtime. Again, query history, if I talk about, so here you can get your query histories, right? Okay, no, not here. Okay, here it is, query history, right? So last 7 days, I don't think I have run. Yeah, we have run. Okay. So these are the query histories that we have run, right? This is the duration. This was the source, right? Compute and everything, right? So let's suppose if you see that, okay, any of the query is taking a long time. Let's suppose this is taking 4.3 seconds to run, right? This is taking 4.45. So I can just click on this and I will be shown that, okay, why this query is taking this much time and how I can optimize it moving forward. Okay. Then we have visualization, right? So if I come here and if I go to dashboards, so we can create the visualizations, dashboard visualizations right here. If I click on this create dashboard, I will be able to create our dashboard and visualize the data that we have, right? Then the dashboard, so a representation of the visualized data and commentary. You can use dashboard to automatically send report to anyone in your the Databricks account, right? Already aware about it that if we want to visualize the data on a graphical kind of interface, right? Then we can even create the dashboard inside the Databricks environment also. Cool. Now let's talk about the integrations. Okay, what all integrations are there in the Databricks environment? So the article are listed here to provide the information about the large assortment of data sources, BI tools and developer tools that we have in the Databricks. Many of these are available through our system partner and our partner connect hub. So the very first thing, the partner connect hub. So if I come here and if I go to this marketplace, okay. So here you will be seeing connectors of multiple organizations that we can use to connect to their platform. Okay. Let me just refresh it. Okay. So, okay, here you can see we have multiple providers. This group, right? Axiom. If I talk about any well-known company, do we have here? Mm, 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 mm. Maybe even I'm not aware about any of the like vendor. So this Crunchbase is the company, one of the well-known companies that I am aware about. Okay, right? Mostly like DBT, right? One of the most used ETL tool, right? So DBT is there, and all these companies, they are very large companies. Maybe I'm not aware about these companies, right? But all of them are large companies that have their connectors ready to be used. Okay, if I click on any of them, we can see what all connectors do we have, right? If we want to ingest this particular data and table, we can get this access for free. Okay, so this is basically, I guess, uh, Monda, if I'm not yeah, so this is a financial company, right? So these are the things that we can get and all those stuff. So this is how we can integrate using the partner connector. Then we have data sources. Again, we are already aware about this. So if I click on this new and if I click on this add upload data, so we have a multiple connectors. I guess more than 50 plus connectors are there that we can connect to. We can connect to OneDrive, Google Drive, right? Airtable, our Apple App Store, Apache Kafka we can connect to, right? If I click on, let's suppose Apache Kafka, I can just click on this warehouse. I can do this, right? If I let's say start, okay. So I will have to do what from Apache Kafka. I can connect to my Fivetran. Again, Fivetran is a kind of ETL tool that we have, and Fivetran will get connected to this. Like if I click on next, okay. So I will have to pass my personal access token here. I can give the personal access token, port name, and all those stuffs, and I can click on this connect to Fivetran, and it will be connected. Okay. So this is how a kind of no code platform or even a no code connector we have here. So data sources, so Databricks can read data from data and a variety of data in the form of a CSV, Delta Lake, JSON, Parquet, XML, and other formats, as well as from storage provider like Amazon S3, Google BigQuery, and other cloud storages, Snowflake, and all those things, right? Here, if we go, so for sure we will have S3 here, right? S3. Do we have in S3? It should be there in Amazon. Here we already have, right? Amazon S3, right? So we can easily connect to our S3 and get our data ingested. Then talking about the BI tools, again, if I come here, we can have several BI tools, right? We can have BI tools were there for connection, right? We can connect BI tools using this marketplace, right? If I go to marketplace, right, and here if you see, so you can see Power BI desktop is there, Fivetran is there, right? DBT is there, Prophecy is there, Tableau is there, and all these tools can be connected. So here if I talk about, Databricks has validated integrations using your favorite BI tool, Power BI, Tableau, and whatnot, and we can connect it very easily. Other ETL tools, right? We have ETL tools like DBT, Prophecy, Azure Data Factory, and all these things. Pipeline orchestration tools like Airflow, and database tools like Datagraph and DB Weaver to be connected. Then talking about the IDE, so we can very easily connect to the IED like IntelliJ, PyCharm, VS Code, and all these things, where it will allow you to programmatically access Databricks compute and SQL warehouses. Okay. Then talking about Git, so we are very well aware about this, that if we want to do the code versioning and we want to maintain the history of our code, we can use Git for doing that particular thing. Okay. So these are the integrations that we have inside our Databricks. There are multiples of integration, right? The most used tools we can very easily connect in the Databricks, right? So this was pretty much it for this particular video. I hope you learned something new in this video. I will see you in the next one. Till then, keep learning and keep growing. Bye-bye.